All right.
Just with pixie dust.
Let's hope I haven't been logged out while I've been doing this. So what you see right now, this is a early access of 2.0. We're not done yet. That's my caveat in case something breaks. But it's all true. What you see is the dashboard, and we accumulate the information up from the IOPS and bandwidth. 5 minutes to do this, which is great. You'll see the accumulation of all the files. It's not that many files in the system. I was sitting in the airport trying to desperately create more data from the few clients I had. So you see this massive data growth the last day. We trapped this. And obviously, anything you see in our product can be extracted and used using REST APIs. Our UI is simply a layer on top of the REST API infrastructure, or what we decided to expose to the current piece. I'm going to go talk through the objective that we just talked about, because that was the one I promised to talk about. Snapshot Back Up. This is a really interesting piece. This is a rule you would set on a file or on a share. Usually a share says, if it's a snapshot and it's been inactive for more than 48 hours, move it to the cloud. As in, I haven't seeded into .snapshot and touched any files in that snapshot. Remember, we track everything in our system, including a file that sits in a snapshot. If someone, if it's less than that, keep it on-prem. DSX to me is my on-prem storage tier that I happen to have, all right? And then you can say, for anything else that's not snapshots, when it's 4 weeks or older, move it to the cloud, and obviously keep it on my NetApp, place on NetApp, and if anything less than 4 weeks. Just two examples on how you would very easily, in just a couple of lines of code, do something that would be extremely difficult to achieve without interruption for a single application.
When you say snapshot hasn't been touched in 48 hours or 7 years or whatever, you're actually talking about the files that really represent that were copied into the snapshot.
It will say the data in the snapshot, if there's modified data that lives in the snapshot, right? Because it's copy on write.
Yeah.
If it's older than 2 days, I'm going to move that piece of file into the cloud. If you go back and touch it, I'm going to bring it back into our system and put it on DSX. It's going to leave it there for 2 days, even if it's a month later. Then it's going to move to the cloud again. So the system is kind of self-adjusting from that perspective. You don't have to put these rules to cover all these scenarios. So that's one example of a nice objective. I have another one that's more traditional. Guys will love this, won't you? This is what I like with our objectives, where it's a 3-tier storage architecture. And remember, I showed you that screenshot with all these parameters? We've written an expression language that you can literally program the system to do certain things. So you can use this, almost, it's hard to read in the room, hopefully online it can be visible better. So you can use this if and expression, say if any file older than this access age, move it to this storage level. And it only sits in the live file system. Right? So you can program the system to place and move data.
If you create a policy already, can you then see what that would look like? So you could then go and modify it later on?
Yes and no. You can see some of that today. Give me another maybe quarter, and you'll see it all in the UI. Because we have all the data, we just haven't presented it out yet. So what you'll see is when you create an objective, and we have these sliders. I won't go through and create one for you, but when you have a ABC, you have these sliders, and you'll be able to set these time ranges, and you'll see the number of files, the amount of data affected depending on the slider. And it'll be dynamically updated. You can say, how much data do I have that's older than 2 weeks? And you'll just see it instantly on here. And that's what this is analytics we're going to be doing in the back end. So in order to do that, you obviously can't probe a billion files in a few seconds. We're going to continue running analytics in the back end to provide you with these data points. So when you do these operations, you'll be able to do this. Sorry, what was the question?
Can Snapshot be exposed as a file directory, or does it have to be restored before it's exposed as
No, it's available in .snapshot. So if I browse a share, I'll show you. So
it can be read or just read in .snapshot.
Yeah, so it's an artificial directory. It doesn't exist.
Yeah.
It's generated by our metadata server. So in any directory, if you do an ls, you don't see it. If you just seed into .snapshot, it's there, and you'll see the snapshot you have rights to see based on whoever user you are. And it's available in every directory. And it's generated on demand.
And it's read-only.
Yes, absolutely. Yeah. You can clone data out of a snapshot to make it read-write.
Right, you just copy it out.
Yeah, and if you're familiar with a command called cp-reflink, and if you're not, you should Google -reflink. We fully support that from a client. That's a space-optimized copy. The other one I wanted to show you was the way we have for visualizing mobility over a large number of files. It's called a chord diagram. You can highlight, it goes from dark to light, from where data mobility starts. Especially when you have a large number of storage systems, you're able to very easily visualize where data has moved, and you can specify the shares, the time ranges, and so forth, and the reasons why data moved. So it's easy to figure out in the large system, hey, what's moving, why is it moving, and where is it moving? The other piece, the last few minutes here, if you look into a share, for example, you want to see the capacity growth of that share. You can see what volumes and storage system is hosting this share and how much capacity they're being hosted at. And you can see, you can click on one of these and go to, hey, are they not healthy? Are they healthy? And figure out very easily, where's my data? Is something affecting availability of my data and so forth? Everything is green in this particular system. In reality, you might have a few systems that are not as healthy. And we can give you visibility into what data is impacted by a system that's not healthy. And finally, if you look at a storage system as an S3, for example, you'll see a couple of things. You'll see the physical space being used and the logical space being used. Right? So you'll see the deduping effect. In this particular example, it's not super impressive efficient ratio because when I create files, I use random data, but I've uploaded the same file several times, so it does have some ratio and impact. But it gives you an idea of how you want to model this. And you can also see the performance and how files are aligned on that as well. I know we're running up to the hour on time. Any questions that you have, that is something you want to see in AU? We went through a lot of information the last hour.
So I noticed you talked about HTTPS for cloud access, but you're not actually encrypting the data. You are deduping and compressing it, however.
Yes. We do compression because that increases the safety of the HTTPS transfer, which is due to for obvious reasons. The encryption is something we can do. We just haven't embarked on that yet. And
you said you coalesce multiple files into one object?
No. So one file will become multiple objects, depending on the size of the file. So we chunk the file, and this chunk size depends on the content of the object and the dedupe ratios you're essentially going to see. So you'll see file sizes that are very small, and you'll see one large file might have hundreds of objects up there. The benefit of that approach is that when we pull things back, let's say I'm going to take the virtual machine example. I've archived a VM out. It's been dead for 3 months, and then someone powers it on. They have no idea it sits in the cloud. And the VM will start booting. It's not going to fail boot. It's going to take a long time. So it'll actually start reading the data as the data comes back. We'll present it coming up. So when those chunks come back, we'll reinflate them. We'll present them obviously in the order they're supposed to be presented. And the VM will boot up. A little bit slowly, but it won't wait until the whole file is downloaded and come back up. Because Windows might be able to boot with the first 20% of the data coming back, and then the rest doesn't matter, right? So the system is dynamic from that perspective. I should mention a very neat feature for anybody that cares about reports. You can click this little icon up to the right in the window, and every time you do that, you get an Excel CSV sheet of whatever is in the table. So if you don't like the way we plot things, you want to plot it differently, you can absolutely do that as well. Because there's some tables we have that are very large that you can extract data differently from. And all of those are REST API calls as well. If you want to download it regularly through some reporting tool, you can do that as well.
Quick question, licensing based on?
We license the DataSphere based on the number of nodes you have. We also license the DSX nodes. Okay. And we license the client access. The client access tends to be very low in cost, so I wouldn't be stressing too much about that.
So it's really the infrastructure, how many?
We're not capacity based.
Okay, that's really where.
And we're subscription based. So the customers can try us out and use us for a year, and if they don't like it, they don't have a 3-year cost. Right.
And they can start small in a little environment and then decide it is working, we can scale this, and not go, okay, somebody bring out the checkbook and.
Exactly. And that's the whole point of two products. Obviously, we're able to enter in environments that are smaller, and also as a nice entry level.
From a security and compliance standpoint, so you have domain this is domain attached. So do you have the ability to export the logs of, for example, all user accesses to all files to a SIM platform, something along those lines?
We don't do it today, but we can because the logs are there. There's more about someone asking me about it. I'll give you a REST API to extract it. You can redirect messages. We have full SNMP support, and all the basic stuff is there in the product as well. You can, if you want, start redirecting syslog messages. We haven't officially turned it on yet, but it's there as well. So that's just another way we can extract another log file out. Yeah, and I'll give you a taste of what we'll do probably in the future. We can do chargeback on IOPS because we track every IO into the system. We know what files they go to and what client they came from. We don't expose it today, but all that information is coming back to us. We discard it after about 7 days today, but it will be easy to export that periodically to another system and give someone IOPS-based chargeback. That's kind of for the service provider use case on the capabilities. And it's just built into the telemetry coming back.